Okay, stats, we're just going to be super confident now about using a scatter graph, drawing a line of best fit on it, interpreting the correlation, describing it and interpreting it, but also saying whether estimates we make are good or bad. So first of all, I'm going to draw the line of best fit. There. So I'm going to describe the correlation. It's positive, and I'm going to say it's quite strong because the points are lined up pretty neatly. Interpret, I have to go back to the question. So students are spending time on revision on a website, that's one of my variables, and then what they scored in their exam is the other variable. They are positively correlated, so when one rises, so does the other. So more time on the website is linked to, remember that we can't say it's causing, but it's linked to higher score. Okay, so make sure that you are super confident. Keep practicing with that. Now we're going to use our line of best fit to make some estimates, but one of our estimates will be good and one of our estimates will be much less reliable. Estimate the mark of a student who spends 10 hours on the website. I'm going to go across. Counting my tiny squares, that is a mark of 62. Now I'm going to say this is a good estimate, and the reason it's a good estimate is because it's within the actual data. Okay, that's called and it's a good estimate. It's say do that, so it's a good. Use the word interpolation if you like, but you could also say within the trend of the actual data. Okay, now I'm going to estimate what the mark would be if somebody spent 20 hours on the website. Now have a look at this. You can't actually go, well, we don't know, but you possibly can't go above 100 in an exam. But certainly it seems to indicate that we would get at least 100, and if this is percentages, it would have to obviously be 100%. So I'm going to say it would be 100%. But the problem with this estimate is it's actually out of the range of the data. Okay, so it could be that the highest that anybody has ever got in this school is 90, and it doesn't matter how long you spend on a revision website, they might always throw some really tricky, unusual questions at people. So we don't know, and that's the real point. That's the point I'm trying to make. We don't really know. We can make an estimate, but we have to say our estimate isn't very safe because it's outside the trend of the data. So I'm going to say 100, not a good estimate or not a safe estimate, as trends do not always continue. Okay. So in a question like this, they might have worded it differently. They might have just said, Boris says, I'm going to spend 20 hours on the website, so I will get over 100%, or I will get 100%. Evaluate his statement. Or you might say that Boris says, I'm not going to bother spending any time at all on the website, I'll still get 22%. So you can evaluate those two statements and say, well, they're poor statements or they're poor estimates because they're outside of the range of the data. Okay, so have a look at the we do now, please. You have to go. So just notice what you need to do and do it carefully because these are marks to be picked up. So you've got a scatter graph now showing information for some weather stations, like little kind of sensors that send back information. So, you know, on temperature and precipitation and that kind of thing, air pressure. Okay, so you've got some weather stations and they've gathered some data and they found that you can plot on a graph the height of the weather station above sea level, so how high it is, and you can have a think about how hot it is at each place. And they've plotted this data. So can you tell me, please, what is the correlation? Positive, negative, none, weak, strong. Okay. But could you also interpret? So you're either going to be saying higher means higher, or you might say higher means lower. Okay, you don't have to do it that way around. You could say lower means lower, or lower means higher. It doesn't matter, but you need to show whether the pieces of data are rising, or when one rises, does the other fall. You must use words from your question to get those interpretation marks. And then I want you to make 2 estimates and say which one is good and which one is bad. Off you go. Pause the video. Here we go. Here are the answers. I've I've drawn a line of best fit onto my scatter graph, and then I've said that this is most definitely a negative correlation, and that means that the higher one piece of data or one variable is, the lower the other variable would be. So you can say it this way around all the other, but you must show that when one rises, the other one falls, and you must use words from the context, from the question. What was it they were talking about? Now I've drawn a line to show what might happen. How high might a weather station be if the temperature was only 4 degrees? So I've gone right up, and it's right off the end of my data, so I extended my line of best fit, and I've estimated to 750. But what I've said about that is it's actually not a reliable estimate. It's extrapolation outside of the trend. And the easiest way to explain why that's a problem is to say that trends don't always continue. It might be that this was the highest that any weather station could possibly have been. So it must have been around about this height, but just unusually cold. Okay, so just be careful. You can't assume trends continue. And then we were asked, question 5, to estimate at 16 degrees, and this was much safer because it was within the trend of the data. I went across and I estimated that that weather station was 1350. 1350, reliable within the trend of the actual data. Okay, brilliant. Thank you very much for listening.